Hi everybody, today we're going to look at the balancing method and see if we can figure out how this all works. It's relatively simple, but it can be overwhelming to begin with. So with the balancing method, we can assist, the balancing method can assist finding the quantity of an unknown. So here's an example, 2x plus 1 equals 7. And if we look at it, it's 2 times some number plus 1 is 7. Now this value here is unknown, but we can figure it out quite easily. 2 times what plus 1 is 7. By inspection we know that it's 3. Now we need to know a few things before we can use the balancing method. The first is the left hand side must always equal the right hand side for an equation to be true. If we perform the same operation to the left hand side and the right hand side, the equation remains true. Any number multiplied by 1 is itself. The number 1 can be represented by infinite number of fractions. And if we add or subtract and the sum equals 0, the elements of the sum can be eliminated from the equation. Now this sounds very confusing, but when we're doing it in practice, not so bad. So let's look at the first part. The left-hand side of an equation must equal the right-hand side. Using our example above, 2x plus 1 equals 7. If we substitute 3 where x is, 2 times 3 plus 1, 2 times 3 is 6 plus 1 is indeed 7. This equation is true because the left-hand side of the equation, this part, is equal to the right-hand side. That's 7, this is 7. But if x was 2, this wouldn't be true. 2 times 2 is 4 plus 1 is 5. The 5 on the left-hand side does not equal 7 on the right-hand side. This equation is not true. And typically, to show that an equation is not true, we'd write it as 2 times 2 plus 1 is not equal to, equals with a line through it, 7. 2 times 2 plus 1 does not equal 7. And that kind of makes sense. Now the balancing method relies on, at all times, both sides of the equation being true. And there's a bit of a trick to it, and I'll show you what that is. So with the balancing method, as long as we start with a true statement, if we perform the same operation to both sides of the equation, it will remain true. So let's have a look at a simple arithmetic sum. 2 times 3 plus 1 equals 7. 2 times 3 is 6 plus 1 is 7. The left-hand side equals the right-hand side. It's a good place to start. Now, as long as we do the same operation to both sides, we can see that the equation remains true. So if I add 1 to the left-hand side and I add 1 to the right-hand side, they're still equal. 2 times 3 plus 1 plus another 1 is 8, and 7 plus 1 is 8. The left-hand side is still equal to the right-hand side. Similarly, if we do it with subtraction, if I take 1 from both sides of this equation, 2 times 3 plus 1 is 7, take 1 is 6, and 7 take 1 is 6. The left-hand side remains the same as the right-hand side as long as we do the same operation to both sides. In this case, I've decided to divide both sides by 2. If I divide this side by 2, I get half of 7, and if I divide this side by 2, I get half of 7. They're still equal. And last but not least, if we multiply both sides by 2, this side will now be 14, and this side will now be 14. They're still equal. And it's this idea that we use to solve an unknown. Now, if you can imagine, we've got that sum that we started with right at the beginning. We've got 2 times x plus 1 equals 7. We want to know what x is, not what 2x plus 1 is. So what we're going to try and do is eliminate the 1 and the 2, put it on the other side of the equation by adding and subtracting, multiplying and dividing. So this is a bit of a leap of faith at the beginning, and then it becomes very natural over time. So if we start with 2x plus 1 equals 7, if I subtract 1 from this side and I subtract 1 from this side, this plus 1 over here is going to become eliminated. Watch what happens. 2x plus 1 take 1. 1 take 1 is 0. It will just be left with 2x. And 7 take 1 is 6. So we've simplified this equation from being 2x plus 1 equals 7 just down to 2x equals 6 now. Now if we continue this process and divide both sides, 2 times 2 lots of x equals 6. Well, if I divide both sides, I'm going to have 1 lot of x. 2 lots of x divided by 2 is 1 lot of x. And 6 divided by 2 will be 3, and that's what I've done here. Now, algebraically, we can see that this is true because if we expand this fraction here, we end up with 2 times x, 2x, and 2 times 1, which is 2. And we know that 2 over 2 is 1. And any time we multiply a number by 1, it's itself. And all of a sudden, we've eliminated this whole complicated equation that we started with at the beginning, right down to just x equals 3, which is the solution we expected from inspection right up here at the top. Now, practice and a bit of knowledge, you'll know to do what operation, and we're going to practice that in the next one. So thank you, everybody.